Hello guys, welcome to my YouTube channel. So today we'll be solving Codeforces round 907 tip 2 problem A sorting with 2's. Okay, pause the video, read the question, then I'll explain. Okay, cool. So in the question, what it's saying is we'll have one array and then we can do one perform operation. And what is that operation? We can choose some number m such that 2 to the power m is less than n, and then we can subtract 1 from all the AIs. What it is trying to say is, so let's say I have number something like a1, a2, a3, a4, a5, a6 dot 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 till an. Okay, now I can select some number m such that 2 to the power m should be less than equal to n. Okay, now what I can do is, let's say I selected m is equals to 2 and n was, let's say, 7. Then 2 to the power 2 to the power 2 is equals to 4. Then I can 1 a1, a2, a3 and a4. So I can subtract 1 in this all these values, not like a5, a6 and a7, not from this but only from this. Okay, so whenever I'll have to select in such a way that 2 to the power m should be less than equal to n. That means I can, like, or if we talk in the terms of number of elements, we can say that if we'll select for m equals to 0, we can select one element, that is 2 to the power 0, that is equal to one element. If n is 1, m is 1, sorry, then 2 to the power m, two elements. If we put m equals to 2, then we will be selecting four elements. Similarly, 8 elements, 16 elements. So from here, what we realize is, let's say if this is our array, this is array. What we can do is, first of all, we can either select one element, two elements, or four elements, or 16, or sorry, 8 elements, or similarly 16 elements, right? So, and okay, so that's the operation. And yeah, whenever we select, we can decrease all the values. So let's say if we're selecting four elements, then we'll have to decrease all the values by one, all the values starting from the 1 to 10, whatever the value we have selected for that particular m. Okay, now the question is, can we sort this array non-decreasing by performing some operations? So that is our end goal. So we know the operation, we can select some m and subtract all the elements minus 1 till 2 to the power m. This should be less than equal to n. Okay, and we have to sort it. So let's say if I have some number a1, a2, a3, a4, a5 and a6, let's say till here. Now I know that I can select this a1, right? Because if I put m equals to 0, I'll be selecting this one element, because 2 to the power 0 equals to 1, right? So let's say it doesn't matter whatever the value we have for 2, right? I mean, let's say if if this was 2 and this was 4, then it's fine, it's already sorted till here. Okay, but let's say if it was 2 and it was 4, then also we know that we can just select this element and keep on decreasing till it becomes 2, right? Then in that scenario, what will happen? This all two numbers become 2. Okay, but let's say if I selected m equals to 2, let's say, then in that scenario, I'll have to check for this numbers. I'll have to check for this number. So let's say if this number was 2, 3, 4, 5. Okay, then first of all, it's already sorted. Okay, but if we'll perform this operation, what will happen? This will become 1, this will become 2, this will become 3, this will become 4. But let's say if something like this happen, 2, 3, 5, 4. Okay, now if we'll start with m equals to 0, we'll start with m equals to 0. We can see we don't need to perform any operation because this was already lesser than this value, right? If we'll put m equals to 1, then we can select two elements and we see everything is fine. This is already in increasing order, right? But if we'll select m is equals to 2, then we'll have to select four elements. And now see, if we'll perform this operation one time, then it will become 1, 3, 4, 3. Sorry, 1, 2, 4, 3. If we perform 1, then it will become 1, 1, 3, 2. So no matter how many times you will perform this element will always be greater than this element, right? And this will fail, this will never be able to sort, will never be able to sort in non decreasing order. So how or what we are realizing over here, Whenever we'll sort right, first of all, we can either select one element, we can select two elements, we can select four elements, or we can select eight elements, or we can select 16 elements. So see, we if this is sorted, it's fine. We can say that this entire part or this part is sorted in all the elements or all the values if we select for m equals to 1 2 3 4 anyway. Okay, now if here it was one element, right, here it is two element, so we know that if this is, let's say, 4, this is 3, right, we have make it sorted by making it 3. Okay, now this is 3 3, this is 3, this is 3, then we'll have some value 4 and 5. So in that scenario it is kind of sorted, right? And we know that we'll always decrease every element by 1. So if this was something like some line like this or something like this, doesn't matter, it will just shift one position downwards, right? So the new graph will look something like this if we'll select this value. But let's say for this scenario our graph looks something like this. Till here it was okay, fine, no issues, but it went constant and then it kind of dipped. It doesn't matter, it can also dip, nothing, and then it also goes up. So no matter what, no matter how what, we we can do anything, but this graph, it will always follow this line only, right? This will always follow this line no matter what, how many operation we perform. So from here what we realize is, if we want this to be sorted, we have to, we have this part to be sorted, because if it doesn't matter, here it's 3 and here it's also 2, then also we'll be able to sort it because we were able to pick a smaller part from here. Similarly, we'll have to check this part, for this we'll have to check the remaining part. So what I am trying to say is, if this is the line, first two elements, sorry, first element, second element, fourth element, eighth element, and 16 element, and so on, right? So if this is okay, this is one element, so it doesn't matter how it looks like, but here to here it also should be increasing. But see, here you won't understand much, because we can always decrease its value here, so we can always make this increasing. It is not an issue. But if we have this third element over here, right, if third is lesser than this, if third is less than, let's say, here it was 5, here it was 6, then it's fine, because we know that this value can be decreased to this level or this level or whatever level we want, right? And this can be dropped till this level. But if here it is 4 and here it is 3, we know that this graph is something like this, or the slow graph is something like this. So if we will decrease this, then also it will always be something like this only. So we'll never be able to sort it. But if it say it was like this, then it's okay. We'll either we can put it here, we can put it here. So whatever will be the required value, we'll put it. Okay, if this needed, we will push it down, then we'll keep it as it is, or whatever needed, we can perform it. Similarly, we'll check for this slope. So what we will see, first of all, we are checking till 1 2, then 2, then till 4, then till 8, then till 16, and we are always starting from the first position after the all the checking. So first of all, how can we run a loop for j equals to 1, and we'll check the previous elements. So why I'm doing so, because just to, it's a zero based syntax, so j less than 1 I'll consider for the first time. Or what I'll do, I'll do a starting index and where it should end. So initially it should be less than 1, that is 2 to the power 0, right? Because we are following 0 index, and if we'll put m equals to 0, it will be 1. Ideally we had to take first element, so first element it will have index 0. That's why I'll have it less than 1, j less than 1. Then in the next iteration, j should be less than, it was 2 to the power 0, it will be 2 to the power 1, that is equal to 2. Then in next it should be 2 to the power 4, right? And we'll check from j equals to 2 to j less than 4. We'll check if it is this line or this line, or what does this mean, that a of I is always greater than a or equal to a of I minus 1. then we'll get this kind of line, right? I mean, this can also be something like this, but it should always increase and constant, but it should not decrease, right? So if that satisfy, then we can do. But in any slot or in any interval, if this get violated, then we can't have our answer. I hope that would have been enough explanation. You would have got it. But if you don't, let's go through code once. It would make more clear. So first of all, we took the input and then we started initially. It should be less than 2 to the power 0, or we have to just take one element, right? So the index of one element will be 0. So we'll have to take till 0. So initially, yep, what we are doing, first of all, we are taking one element. We are taking going slot by slot, right? So we'll be starting with the first index, or in this scenario we can simply just go for, sorry, yeah. So what we'll do, initially our j was 0, so starting at the first, we are checking if that is okay, then it's fine. Else what we'll do, so initially p was 1, right? So if j was 1, p was also 1, so we don't need to check, because in that scenario we are just taking the first element, so that will always be sorted. It doesn't matter. Now we have to check from where to where. So on the number line itself, right? On the number line we saw, let me make another one. So on the number line, what we saw is the first element, second element, fourth and eighth, and so on. So if we index will be 0, 1, 2, something like that, so we have checked till here, then we'll have to check this one, right? So we can update j as well, and p will be here. So initially p was 1, then p will become 2, then p will become 4, then p will become 8. Initially we have to, check always elements in the pair, right? So initially this was one element, so it doesn't matter. But for here we can start with j equals to 2, right? So that's what we are trying to do. When the first iteration j was 0, then j was 2, and we have multiplied p by 2. Okay. So but, and we are checking if the slope we already discussed, if it's not in this, if there is some kind of this downward break, then we'll simply see out no and we'll return, else we can simply see out yes. Okay, I hope this should be clear to you. Let me know in the comment section if you guys have any doubt in this question. Thank you.